function notation. What the heck is function notation? It's only one word. We're only going to define one word right now. Pretty easy note session, Rodriguez. Function notation is, watch this, replacing the y value with function notation or function symbolism f of x or any other name. Replacing the y value with function symbolism f of x or any other name. Write that down. Underneath notes, I'm going to put example. I'm going to make up a function off the top of my head, but making sure the function has a y and an x. Off the top of my head, y equals negative 5x plus 2. Write that down. Right, Garcia? Remember, if you want that third or the last stamp, you need to be like not having phones out when I have the floor. FYI. So look what I'm going to do. I'm going to change this to function notation. Y equals negative 5x plus 2. The higher level mathematicians, when you get to calculus and higher differential equations, engineering math in universities, when you have a two variable equation like this, a function, they replace the y with f of x. The function at x equals negative 5x plus 2. We call this function notation. F is the function name. X is your input value. And the way we say it is, I'm putting quotations, the way we pronounce it in the English language, we're going to speak English, the way to say this is f of x. F of x. Okay. Then underneath that, so this is the first bullet, put another bullet. Put f of x does not mean f times x. A lot of people see f and x like this and think this means f times x. This does not mean f times x. This means the function of x. The function of x. It's a way of notation for higher level mathematics. We're tempted since junior high, if you see a letter next to another letter, you think this is multiplication, but it does not mean multiplication. This does not mean f times x. So make sure you understand that. This is just a way of noting the function machine. From now on, whenever you see y, you can replace it with f of x. F of x means y, and y means f of x. They mean the same thing. And you don't necessarily have to name it f. You can name it any letter you want. For instance, example 2. Y equals x squared minus 4. Gotta write that down. Let's change that to function notation. change this to function notation. I'm going to replace y, and I'm going to replace it with function symbolism. But instead of f of x, I'm going to use a different letter. Shem, what's your favorite letter? Thomas, help him out. Give me your favorite letter. Rodriguez, j of x. Okay, let's go j of x. J of x equals x squared minus 4. Notice I changed it to function notation. This is the function name. The function is j. This is your input values, and everything else stays the same. The point here is that you don't have to have f for the function name. It could be any letter. J of x. Okay? So everything's the same. You're used to this y and x. The only difference now is that instead of y, you're going to put function notation. Because higher level mathematics involves this kind of notation versus this. All right, last thing. You guys are doing good. I'm going to flip the page. Where it says extra practice here. Or I think it's the third page. Skip all the stuff in between. Go to the third page where it says extra practice. Look what it says here. In exercise 1 through 6, evaluate the function when x is equal, when the input is -4, when the input is 0, and when the input is 2. What is the function's value when x is these inputs? Well, let's take one at a time. So on number 1, wherever I see the input of x, I'm going to replace with -4. So watch this. The function at -4 equals negative. There's a -1 in front of x's, which means there's a -1 in front of it. So I'm going to put -1 times x now. I'm replacing x with -4 plus 4. Say that with me. Look what I did. I'm going to evaluate f of x when the input is -4 first. And then I'll evaluate when the input is 0. Then I'll evaluate it when the input is 2. We're going to do it together here. We'll just do the first two. Sir, my bad. I gave you 4 papers. There's 4 of them, right? So the third one. Show them, Janina.
You can give me a sec.
What did you say? What was that? Oh, okay. Okay, it's autograph later. All right, here we go. So watch this. The function, remember the machine that spits out the cows, it spits out the nuggets? The function with the input of -4, watch this now. What's -1 times -4? Right, it's +4, huh? Negative times negative. So watch this. The function at -4 then is going to be 8, huh? Done. I evaluated the function when the input is -4. Right there. Okay. You have some space on top there. You might want to do the next one 0. I'm gonna put it at the bottom. You have to find space on your own paper. It's gonna get a little crammed, but you might want to do it in the back because it's blank. But I'm gonna evaluate number 1, the function now, when x is 0. So the function at 0, they want me to do it for 3 different inputs. The function at 0 is equal to -1 times 0 plus 4. Again, the reason why I'm writing a negative 1 there is because you have a negative x. That means negative 1 times x. I'm replacing x with 0. Here we go. The function then at 0 is going to be negative 1 times 0 is 0. 0 plus 4. The function at 0 is going to be 4. We're rocking and rolling. 2 down, 1 more to go. So look at what we've done. We've evaluated this function when x is negative 4. Check. We've evaluated the function when x is 0. Check. Let's evaluate the function when x is 2 now. The function at 2 then is equal to, I'm going to rewrite the function now. Negative x, that's negative 1 times x, plus 4. The function at 2 then is going to be, multiply before you add, that's what, please excuse my dear Aunt Sally says. Negative 1 times 2 is negative 2, plus 4. The function at 2 then is going to be positive 2. Look at the way I write my final answer though when I evaluate. The function at 2 is 2. The function at 0 is 4. The function at negative 4 is 8. This is the new type of notation now that you have to adjust in your mind. You have to make that adjustment up here. When you're in junior high and middle school, it's always y is equal to something. Y is equal to this. Now it's f of something. F at negative 4. F at 0. F at 2. Instead of y. Yes, sir.
So if it doesn't give us the numbers to multiply, then can we put it all numbers? That's just, for example, if it didn't give us negative 4, 0, and 2, I think.
Right.
You put it all.
Yes, you can use it. In other words, you're talking about a situation where they ask you to graph it, for instance. Yeah, you can make your own table of values. Pick your own x's. Good question. All right. I'm going to skip number 2 right now. Watch this.